Liza Rubrigaldo, and now let's talk about exponential distribution. Theorem 15. If x has an exponential distribution, then our expected value of x is equal to 1 over lambda, our variance is equal to 1 over lambda squared, and our moment generating function is lambda over lambda minus t. Proof. Our moment generating function is equal to expected value of e to the tx is equal to integration of e to the tx function x with parameter lambda dx evaluated from negative infinity to infinity. According to definition 12 exponential distribution, that if a random variable x has a density given by function x with parameter lambda is equal to lambda e to the negative tx, indicator of x from 0 up to infinity. So, we have integration of e to the tx, the quantity of lambda, e to negative lambda x dx evaluated from 0 to infinity is equal to lambda integration of e to the tx times e to negative lambda x dx evaluated from 0 to infinity equal to lambda integration of e to negative the quantity of lambda minus t times x dx evaluated from 0 to infinity. Let u is equal to lambda minus t times x, and our d is equal to negative the quantity of lambda minus t dx, and our du over negative the quantity of lambda minus t is equal to dx. So we have equal lambda integration of e to the u du over negative lambda minus t equal to negative lambda over lambda minus t integration of e to the u du is equal to negative lambda over lambda minus t times e to the u equal to negative lambda over lambda minus t times e to negative lambda minus t times x, which is our u, is equal to negative lambda over lambda minus t times e to negative lambda minus t times x evaluated from 0 to infinity. So we have equal negative lambda over lambda minus t times e to negative infinity minus e to 0, which is we substitute the 0 and infinity to negative lambda minus t times x. So we have negative lambda over lambda minus t times negative 1, which is now our moment generating function is equal to lambda over lambda minus t. Now our m sub x prime times t is equal to lambda minus t times 0 minus lambda times negative 1 all over lambda minus t squared is equal to lambda over lambda minus t squared. So now our expected value of x is equal to m sub x prime, which is our t is equal to 0. So we have equal lambda over lambda minus 0 squared is equal to lambda all over lambda squared, and we have our expected value is 1 over x, which is satisfying our theorem. So we have m sub x times t is equal to lambda over lambda minus t squared. And our second derivative is equal to the quantity of lambda minus t squared times 0 minus lambda times 2 times lambda minus t times negative 1 all over the quantity of lambda minus t squared squared. So we have 2 lambda times lambda minus t all over lambda minus t to the power of 4. If our t is 0, is equal to 2 lambda times lambda minus 0 over lambda minus 0 to the power of 4 is equal to 2 lambda squared all over lambda to the power of 4 is equal to 2 squared over lambda squared. So our variance is equal to expected value of x squared minus the quantity of expected value of x squared is equal to 2 over lambda squared minus 1 squared over lambda squared. So we have equal to 2 over lambda squared minus 1 over lambda squared. So we have 2 minus 1 over lambda squared is equal to 1 over lambda squared, which is satisfied in our theorem. So we have now the example. Assume that the length of a phone call in minutes is an exponential random variable x with parameter lambda is equal to 1 over 10. If someone arrives at a phone booth just before you arrive, find the probability that you will have to wait. First, if we have less than 5 minutes, we have probability of x or greater than equal 5 with lambda equal 1 over 10. So we have integration of lambda e to the negative lambda x dx evaluated from 0 to infinity. We have integration of 1 over 10 e to negative 1 over 10 x dx evaluated from 0 to infinity. So let u is equal to negative 1 over 10 x and our du is negative 1 over 10 dx, which is our dx is equal to negative 10 du. So we have now integration of 1 over 10 e to the u times negative 10 du evaluated from 0 to 5 is equal to negative e to the u evaluated from 0 to 5. So it is equal to negative e to negative 1 over 10 times 5 minus the quantity of negative e to negative 1 over lambda times 5 negative 1. So equal to e to negative 1 over 10 plus 1, which is our result is 0.3934. And if we compute more than 10 minutes, we have the probability of x or greater than equal 10 with lambda is equal to 1 over 10. So we have integration of 1 over 10 e to negative 1 over 10 x dx evaluated from 10 to infinity. So third, if we compute from 5 minutes to 10 minutes, we have probability of 5 or greater than equal x greater than or equal 10 is we have integration of 1 over 10 e to negative 1 over 10 x dx evaluated from 5